This video is on complex numbers. Complex numbers is when you are dealing with imaginary numbers. Imaginary numbers is when you're dealing for any positive b value. So if we have a b of 3, if we take the square root of negative b squared. So if I were to take the square root of a negative number, I'm just going to type in the square root of negative 4. I know that 4 is a perfect square, so I should get something with a 2 in it, because the square root of 4 is just 2. But if I press enter, it tells me error, non-real answer. Non-real is imaginary. That means I cannot take the square root of a negative inside my calculator. I can take, so if I go to math, if I take the cube root of, let's see, 8 is a perfect cube, so if I take the cube root of negative 8, I can do that. But I cannot take the square root of a negative value. So this is really important to make sure you're careful about what you're dealing with. So when you have the square root of a negative, you need to break it up by saying that this is really the square root of b squared times the square root of negative 1, because this is really a negative 1 times b squared. So if I break it up, I can take the square root of b squared, which is just b. Because imaginary numbers you can't do in your calculator, I have to bring that square root of negative 1 out. Well, the square root of negative 1 is possible, you just can't put it in your calculator. So this becomes, the square root of b squared is just b. This is b times, the square root of negative 1 is the imaginary number, because this is what gives us that error. So this is just equal to I. So I'm going to put a little fancy I here, have a little tail on it. So it's not just a regular I, it has a little fancy little tail on it, because this is the imaginary part. So this is b times I. This is not a variable. This is actually equal to an exact value of the square root of negative 1. X is a variable because I can plug just about any number in for x, but I has an actual value. It's equal to the square root of negative 1. So b times I is equal to just bi. So the rule for this, if you're looking for the rule, the square root of negative 1 is what gives you I. So I to the first power, that is the square root of negative 1. So that's just I. I squared, if you have I squared, you're taking the square root of negative 1 and squaring that value, which will actually, is the inverse of square rooting. So the square and square root will cancel each other out, and you'll just be left with negative 1. So I squared has an exact value, which is equal to negative 1. X, so if you're distributing and you do x times x, that's just equal to x squared, because you can't simplify that any further. X squared is just x squared. But if you have I times I, that will give you I squared. And I squared is actually equal to negative 1. So it actually changes. The next one, I cubed. So I would be taking this I squared and multiplying it by I again. So I have negative 1, and then I would multiply it by I. So I cubed is actually just equal to negative 1 I. So it's just equal to negative I. I to the fourth would be, basically I'd be doing I squared times I squared. So I squared is equal to negative 1, but if I do it twice, so I squared times I squared gives me I to the fourth. So I'd be doing negative 1 times negative 1, which is actually equal to just positive 1. So a silly way to remember this would be I won, I won. Like, I won something, I won something. It's a silly way to remember I, then negative 1, negative I, 1. One thing about this is that every fourth time it actually repeats. So technically, I to the fifth, if I were to do this, I to the fifth, I'm going to actually repeat it back to here because it starts back over. This would just be equal to I. I to the sixth would be -1. I to the seventh would be -I. And so forth. So I to the eighth would just be 1 again. So after the fourth one, it actually just repeats again. So this is technically 1, 2, 3, 4. 1, 2, 3, 4. And it would keep going. So it would always be the same thing. So we're going to do just a couple of examples real quick on just simplifying with imaginary numbers, because I cannot put this into my calculator because it's the square root of -25. What this really is, again, we want to split this up. This is the square root of, take the radicand, the actual number from the radicand of 25, times the square root of -1. Because -1 times 25 is -25. Now we can simplify this. The square root of 25 is 5. So we put 5 times the square root of -1 is I. So this just becomes 5I. So the square root of -25 is just 5I. So the next one is the square root of -125. So again, we're going to separate this as the square root of 125 times the square root of -1. Now we have to simplify the square root of 125. We find the biggest perfect square that goes into that. So if we go back to another video of simplifying square roots, we go up the list from 125, which would start with 121, doesn't work. 100 doesn't work. 81 doesn't work. 49 does not work. 36 does not work. 25 does work. So it's the square root of 25 times the square root of 5. And then this would technically still be the square root of -1. So now we can simplify this. The square root of 25 is 5 times the square root of 5 will not simplify, times the square root of -1 is I. So what we do is we put all of our numbers back, we put them together into a final answer. We want our real number 5 first. Our imaginary number, since it's technically a coefficient, needs to go in front of the square root of 5. These are all multiplied together, so we do still take our coefficients and multiply them together. So this gives us 5 from our coefficient times I times the square root of 5. You always want your irrational number at the end because you don't want anything to look like it's inside that radical with it. So this would be our answer. We do want our real number first, our 5, then the imaginary connected to it, because it's still 5 times I, just like this one was. But then our square root of 5 needs to be at the end. Okay. On this next one, this is 6 times the square root of -12. So that 6 is still your coefficient. It's still on the outside. So we have 6 times, we have the square root of 12 times the square root of -1. So we want to do the square root of 12. So 12 we would start with divided by 9. 12 divided by 9 does not work. 12 divided by 4 does work. So we still have the 6 on the outside times the square root of 4 times the square root of 3 times the square root of -1, because all I did was simplify this part, figured out what gave me the square root of 12, and now we can simplify those. We still have the 6 times square root of 4 is 2 times the square root of 3 will not simplify times the square root of -1 is I. Now we again multiply all of our coefficients, which is 6 times 2 times I. 6 times 2 is 12 times I is 12I. So we have 12I, square root of 3 is still inside the radical. This is our answer. So if we keep going, D, square root of -121. So again, this 121, square root of 121 times the square root of -1. So when I see that negative inside the radical, I know I have to end up pulling out an I. The square root of 121 is 11. The square root of negative 1 is I. So that is our answer, 11I. This next one, this time we're actually multiplying them, but you have to simplify this part, the first one first, and then you multiply them. So we have to pull out the I. We have to get rid of the negative inside the radical before we multiply them. So what this one will become, we're going to have 2. I know this is going to end up being 2I square root of 12 times 3I square root of 3. Now that the i's are outside of the radicals, now we can actually multiply these. So the numbers, the 2I, the coefficient of 2I, multiplies to the coefficient of 3I. So this is 2I times 2I times 3I, which becomes, so we have 2I times 3I. Then we have that square root symbol still. Then we multiply the radicands to each other. So we have 12 times 3. So 12 times 3, I'm going to put inside the radicand still. This becomes 2I times 3i. So 2 times 3 is 6. I times I is I squared. Square root of 12 times 3 is 36. Now we just have to simplify this. So 6 times I squared, again, if we look back at our rule, I squared is equal to negative 1. We do have to simplify that. So this becomes 6 times negative 1 times the square root of 36 is 6. So 6 times negative 1 is negative 6 times 6 is negative 36. So that is actually our final answer. Negative 36 is actually our final answer. So you can simplify the square root of 12 before you multiply, but I just think it's a little bit easier to go ahead and get your radicand together and then simplify once from your radicand. Otherwise, you'd have to simplify the square root of 12, potentially simplify the square root of 3, then multiply, then have to maybe simplify again. So you really want to only have to simplify once. So you pull out the I because that negative just automatically will become the square root of negative 1, which is I. So in this last problem right here, I'm going to do the same thing. I know that will become an I on the outside. So I'm going to go ahead and write that. This is really I square root of 8 times I square root of 32. So again, I'm going to multiply my coefficients of I times I. I'm going to have I times I. Then I'm going to have that square root symbol, because now I'm going to multiply my radicands of 8 times 32. 8 times 32. So then this will become I times I is equal to I squared. Square root. 8 times 32 is 256. So now I can simplify. I'm going to simplify just once with the 256. So we're going to have I squared becomes, again, just negative 1 times the square root of 256. I'm going to see if it actually is a perfect square. Square root of 256 is 16. So that is 16 squared. So that means that square root of 256 is just 16. So then that's just negative 1 times 16. So our final answer is equal to negative 16. That is simplifying radicals that have the square roots of negative values. You have to make sure you pull out the I. And automatically, I can take that negative out to the outside and make it an I. And then I'm just left with a positive radicand.